All right, these are the notes for what we call the fundamental counting principle. Now, if you're at home because you are in quarantine and you don't have access to this foldable, then you can either print out the blank copy and not fold it up, just write the answers in the appropriate spot, or I will have a copy of it for you completed when you get back. You can just wait to do that and just watch and learn from the video. I'm okay with that too. So the fundamental counting principle will help us when we get to compound probability on Monday. And compound probability is when I take the probability of a couple different events and put them together. For instance, what's the probability of me rolling a 3 on a number cube and flipping a heads on a coin and spinning the color yellow on a color wheel? That would be compound probability. So compound probability has lots of different outcomes. So one way that we can figure the total number of possible outcomes is by using what we call a tree diagram. And again, this will be your notes on Monday. We'll do a lot of these. How a tree diagram works is you look at what events are taking place. So in this case, it's tossing a coin and rolling a number cube. And you start by taking either one of those two events. So I'm going to start with tossing a coin. And there's two options when I toss a coin. I can land on heads or I can land on tails. And then after that, when I roll my number cube, there's 6 different possibilities. I could roll a 1, 2, 3, 4, 5, or 6. So what I'm going to do is I'm going to focus on my heads first, and I'm going to make branches on my tree. And I have to make 6 branches because when I roll that number cube, there's 6 different possibilities that I could land on. 1, 2, 3, 4, 5, and 6. So you're just telling me what those possibilities are. Okay. Now, if I do that for heads, I also have to do the same exact thing for tails. So I'm going to make 6 branches coming off tails. And again, I'm going to label them 1, 2, 3, 4, 5, and 6. So this is what we call a tree diagram. It lets us know all of the possible outcomes. It helps organize our data so that we can make what we call our sample space. A sample space is just a list of all the possible outcomes, and that's what we're going to do on this page right here. So the total number of outcomes in a probability experiment is called a sample space. Now we're going to list all the possible outcomes for tossing a coin and rolling a number cube. So again, that's when we would want to use our tree diagram to help us organize our information. So how we would list it is we'd start with one branch and we just follow the branches out. So here I have heads and the number 1. So I'm going to write H for heads, 1. That's one possibility. I go back to heads because I'm not done with it. Heads and 2. So H and 2. And so on and so forth. So heads and 3, H, 3, heads and 4, heads and 5, heads and 6. Now, this branch has been completed, so now I'm going to go to my tails, and I'm going to do the same thing. So I could get tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. So if I want to figure out the total number of possible outcomes, I'm going to count these all up, and I find out that there's 12 possible outcomes. So again, 3 things to learn from this. This is a tree diagram. A tree diagram helps us create a sample space, a list of all the possible outcomes. And that sample space lets us know how many possible outcomes there are if we add them all together. There's 12. Now, this is the denominator I would use if I was writing a probability. Like, let's say I said, what's the probability of spinning a 2 or rolling a 2 when I flip a coin and roll a number cube? Okay, well, there's 2 of them that have a 2 in it, so I would say 2 over the 12 possibilities, or 1/6. That's what I'm doing here. Now, to come up with our possible outcomes, there's another thing we can do that's much simpler than following all these steps. If I just need this number right here to figure out the number of possible outcomes, I can do something called the fundamental counting principle. And fundamental counting principle is just simple multiplication. So I can say the number of outcomes when I flip a coin, there's 2, heads or tails, times the number of outcomes when I roll a dice. That's 6. 1, 2, 3, 4, 5, or 6. I could roll any of those 6 numbers. 2 times 6 is 12. So doing the fundamental counting principle, I can very quickly figure out the number of possible outcomes. Now, let's try some more examples. So it says, use the fundamental counting principle to find the total number of outcomes. So total outcomes is what I'm finding. So tossing a quarter, a dime, and a nickel. So when I do fundamental counting principle, I ask myself, how many events am I doing? I'm doing 3 here. I'm tossing a quarter, a dime, and a nickel. So I'm going to make 3 lines with a multiplication sign in between and an equal sign at the end. And then I go through each of the 3 events. So when I toss a coin, what are the possibilities I could land on? A heads or a tails, so that's 2. When I do it with a dime, same thing, I could get heads or tails. And when I toss a nickel, same thing, heads or tails. 2 times 2 is 4, and 4 times 2 is 8, so there's 8 possible outcomes. So that would be something like heads, 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 tails, heads, tails, heads, tails, heads, heads. That's listing all of the different outcomes that are there. What's the possible outcomes when I roll 2 dice? So again, I'm rolling 2 dice, so I'm going to make 2 lines, a multiplication sign in between them, and an equal sign at the end. So when I roll my first die, how many sides are on a die? I have 6 sides with 6 different numbers. When I roll my second die, how many different possibilities are there? Again, it's 6. 6 times 6 is 36. So there's 36 different possibilities of what I could roll. Okay, let's try again. Selecting a month of the year and a day of the week. Okay, I'm selecting 2 things, a month of the year and a day of a week. So I'm drawing 2 lines, multiplication in between equals at the end. So the probability of, how many months are there in a year? There's 12 months in a year. How many days are there in a week? There's 7 days in a week. So I find out there's 84 total possibilities. Okay, I'm getting dressed this morning and I want to figure out an outfit. I have 3 sweatshirts I could choose from. I have 4 t-shirts I could wear underneath, and I have 6 different pairs of pants to choose from. So there's 3 things: sweatshirts, t-shirts, pants. I have 3 sweatshirts, I have 4 t-shirts, I have 6 pairs of pants. So if I multiply these together, it'll tell me how many different combinations I have. 3 times 4 is 12, and 12 times 6 is 72. I have 72 different outfit combinations. Last one. Making a dessert from the choices below. So I have 2 bases, a cone or a bowl. For ice cream, I can choose from chocolate, vanilla, strawberry, rocky road, or mint. And for toppings, I can get sprinkles, hot fudge, caramel, and nuts. Okay? So I get to choose one of each. So I have a base, an ice cream, and a topping. So 3 lines. And there's 2 choices for my base. There's 5 choices for my ice cream, and there's 4 choices for my topping. So 2 times 5 is 10, and 10 times 4 is 40. So there's 40 possible sundae combinations. All right. Now there's a second sheet. So this sheet just looks like this on the front, because this is where we would glue our foldable. And on the back, we have some more examples. So here, again, it's the outfit combination one we kind of already did. So I have shirts, shorts, and pairs of shoes. I have 5 shirts, I have 5 shorts, and I have 3 pairs of shoes. how many different outfit combinations do I have? Well, 5 times 5 is 25, and 25 times 3 is 75 different outfit combinations I could do. Now, the last 3 are a little bit trickier, and there's some things that we have to be careful of. So this one says a quiz has 6 questions on it. 4 questions are true or false, and the other 2 questions are multiple choice with 4 answer choices. How many answer combinations are there? So first ask yourself, how many questions are there? That tells us how many blanks we need. So I'm answering 6 questions. 3, 4, 5, 6. The first 4 questions, so I'm going to cover up these last 2. The first 4 questions are true and false questions, true or false. So how many possible answer choices are there? Well, there's true or false. So there's 2 answer choices for each of those first 4 questions. So I'm going to say 2 choices for the first, 2 choices for the second, 2 choices for the third, 2 choices for the fourth. My 4 true and false questions. Then it says I have 2 questions that are multiple choice. There's 4 answers for each. So here I have a multiple choice that there's 4 answers for, and another multiple choice that there's 4 answers for. Multiply these all together, and it'll tell me how many different combinations there could be. When I do that, I get 256. So that means if you were just given a test without, like a pre-test, and I said, here, you try this without having any knowledge, you have a 1 out of 256 shot of guessing all 6 of the answers correctly. Okay. Your student ID has 5 numbers. How many different combinations are there if numbers can be repeated, but the first digit cannot be a 0? All right, so my student ID has 5 numbers, so I'm going to make 5 blanks. Okay. It has 5 digits. The first number cannot be 0. So here's the first number. I can't have it start with a 0. So how many different number choices are there? Well, it could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So I have 9 number choices for the first digit. Now, let's say it was a 1. Can 1 be any of these other ones? Sure, because it says it can be repeated. Okay, that means a digit can be repeated. It can be used more than once. My code could be 11111. That's a possibility. Okay. Now, here's my second, third, fourth, and fifth numbers. They can be a 0. It says only the first digit cannot be a 0, but the rest of them can be. So now I don't have 9 options. Now I would have 10 options because now I'm going to include the number 0 also. So now it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are my digits that I can use. That's 10 numbers. That would be the same for all of the rest of them. So how many different student IDs are there? If I multiply these together, I find out there's 90,000 different student IDs. Okay, today is the first track meet of the season. Woohoo! If there are 7 people running the 100-meter dash, how many different ways can the runners place? Okay, so how many people are running? 7 people are running. 1, 2, 3, 4, 5, 6, 7. I made 7 blanks. And here's the runner that comes in first place. So at the beginning of the race, how many different people could come in first place? Well, any runner has the possibility of coming in first. So there's 7 people that could come in first place. So then second place, how many different people could come in second place? And some people want to say, well, 7, because there's 7 people running the race. But you got to remember, 1 person already came in first. So how many people are left? There's only 6 people left to choose from for second place. And then how many people come in third place? Well, 2 of them have already been used, so now there's only 5 people left for third place. And then for fourth place, there'd be 4 people. And for fifth place, there'd be 3 people left. And for sixth place, there'd only be 2 people left. And then there's only one person left that would come in last. So if I multiply these together, it'll give me all the different combinations of people crossing the finish line. You know what you get? 5,040 different combinations of people. Now, that could mean, let's say the runners were Jamie, Brian, Kaylin, using my family names, Brinley, Nolan, Brooklyn, and Easton. Okay, so here's 7 runners. Okay, so it could be Jamie came in first, Brian came in second, Kaylin came in third, Brinley came in fourth, Nolan came in fifth, Brooklyn came in sixth, Easton came in seventh. That's one combination. Then it could start off exactly the same, then just switch the other two. So Jamie, then Brian, then Kaylin, then Brinley, then Nolan, then Easton, then Brooklyn. That's a whole separate way, a separate outcome. So it doesn't seem like it would be that many, but when you're just switching 2 of them, it does make a big difference. So there's 5,040 different combinations when you do it like that. So there's a homework sheet that I would like you to try. Please let me know if you have any questions.